In 1905, Einstein revolutionized our understanding of energy and its relation to mass through the equation E equals mc squared. It's probably the most famous equation of all time, but do we really know what it means? Well, according to it, most of us think because light has energy, it should have mass. But how could this be if Einstein also stated that nothing with mass could travel at the speed of light? So what's going on? Does light have mass? Well, to figure out, we first need to know what we really mean by mass. Let's say I'm on a stationary skateboard. What would my mass be? Well, we all are familiar with the matter making up my body and call it mass. Rest mass to be precise. The other type of mass in physics is relativistic mass. It's basically the total energy of an object in terms of mass. So say I'm going down a slope. My rest mass remains the same, but my speed is greater than 0, and so is my kinetic energy. This increase in energy is accounted for in my relativistic mass as extra mass. Thus, we can say that relativistic mass is equal to rest mass plus extra mass. We can also correlate relativistic and rest mass using the Lorentz factor, gamma, a factor by which a change in speed results in a change in time, length, and relativistic mass of an object, which is equal to this. So we can say that relativistic mass is equal to gamma times rest mass. In our daily lives, however, the difference between the two is just too small to notice. For instance, if my rest mass is 50 kg and I'm standing still, my relativistic mass will be the same as gamma's 1. And even if I go at the speed of a Mach 5 aircraft, which is pretty fast, its impact on my relativistic mass is still negligible. But now if I go a lot faster, say 99.99% the speed of light, gamma has a huge impact. My relativistic mass is around 71 times my rest mass, so I seem to be as heavy as an elephant. And as I continue approaching the speed of light, my relativistic mass tends to infinity, meaning I require an infinite amount of energy to accelerate, which is impossible. Therefore I or any other object with rest mass cannot travel at this speed. Light, on the other hand, travels at the speed of light, so I must have 0 rest mass to overcome this problem. But what about E equals mc squared? If I plug in light's mass as 0, it wouldn't have any energy. Well, even though it's the most famous equation of all time, it's not complete. The actual equation looks like this. For objects at rest, it simplifies to E equals mc squared. But for objects without rest mass like light, the equation becomes E equals pc, where its momentum is Planck's constant by its wavelength. As a result, light doesn't need rest mass to have energy. But light is bent by gravity. Well, this isn't because it has rest mass, but because pressure and energy are affected by gravity as well, allowing light to have this property. So even though mass and energy are closely related, we can't always use E equals mc squared as a conversion between the two. Yes, this holds for relativistic mass, but not for rest mass. So in other words, light is massless, but has mass at the same time. It has no rest mass, but has relativistic mass. Thanks for watching.